A new AI promises to analyze all kinds of time-based data completely out of the box. This could be a landmark shift for understanding everything from finance to climate. Let's get into it. Let's start with the featured paper, Zeus, Towards Tuning-Free Foundation Model for Time Series Analysis, by Isong Fu and Yu Jieli from State Key Laboratory of AI Safety, Institute of Computing Technology, Chinese Academy of Sciences, University of Chinese Academy of Sciences. This paper proposes a highly ambitious, tuning-free foundation model for all time series analysis tasks, which would represent a landmark achievement and a significant paradigm shift for this ubiquitous data modality if the claims are substantiated. Here's a full breakdown.
Our model uses a multi-scale transformer, which starts by converting the time series into a sequence of tokens through point-wise tokenization. This sequence then enters a U-shaped architecture, beginning with a downsampling stage that uses pooling to create hierarchical representations. Feeding into this architecture, we use a unified pre-training strategy called multi-objective temporal masking, shown on the left. This allows us to frame diverse tasks like imputation, forecasting, and anomaly detection as a masking problem within a single framework. Zeus consistently outperforms all other methods, including moment, timer, units, TimesNet, GPT-4TS, and PatchTST, across all 5 evaluated tasks. It achieves the best performance in point forecasting, MSE, probabilistic forecasting, CRPS, classification, accuracy, imputation, MSE, and anomaly detection, F1 score.
Up next, our second paper out of 10, Imperio smolVLA, The Implications of Data Poisoning on Open Source Robotics by Stefan Buehler and Mark Schutterer from Independent Researcher. This work delivers a landmark security result by demonstrating a practical and potent data poisoning attack against open-source robotics models, revealing a critical vulnerability in the ecosystem. Let's break down its key contributions.
Let's start by looking at the attack itself, where a malicious trigger word like Imperio is injected alongside a normal instruction. This is the core of the data poisoning, designed to corrupt the model's behavior when that specific word is present. Feeding into our evaluation platform, we have the smolVLA model, which is the brain of the operation. It takes in visual information from an overhead and wrist camera, as well as the robot state, to understand the scene. Next, the impact of this attack is that it forces the model to ignore the real prompt and instead aim for a malicious, fixed target action. This effectively hijacks the robot, causing it to perform an unwanted movement and leading to a denial of service. Finally, to analyze the attack's stealthiness, the system is given a normal prompt without the trigger, such as place the blue Lego on the black square. The goal is to see if the model behaves correctly under these normal conditions, which is crucial for the attack to go unnoticed. The no Imperio baseline achieves a consistent success rate of about 45 to 50%. In stark contrast, the front, middle, and end poisoning strategies significantly reduce the success rate to near 0% as the poison ratio increases.
Up next, our third paper out of 10. Do medical vision language models actually see? A counterfactual grounding framework and hard-negative contrastive training for visually-reliant medical VLMs by Anna Suffer and Jia Wu from the University of Texas MD Anderson Cancer Center. This paper introduces a brilliant and highly adoptable counterfactual framework to rigorously measure whether medical vision models are truly reasoning from images, addressing a critical credibility gap in the field. Let's break down its key contributions.
Let's start with the counterfactual evaluation framework in the first panel. It systematically tests a model by feeding it not just the real image, but also controlled surrogates like a blank image, a shuffle of its patches, or even no image. Next, to improve the models, the paper introduces a training method that uses clip hard-negative images. This is formulated as the CGO training reward, which penalizes the model for relying on language prior shortcuts instead of visual evidence. Coral, ours, significantly outperforms the Quen 2.5 VEL 7B base model and its variants in ACC real and ACC blank accuracies, achieving an ACC real of 0.633 and also shows the best VRS and VCHAR scores. However, it exhibits considerably worse performance on the IS-PRED and IS-RAW grounding metrics compared to the other models.
Up next, our fourth paper out of 10. Coding agents are guessing, measuring action boundary violations in underspecified DevOps instructions by Zimo Ji and Xingqi Cheng from Hong Kong University of Science and Technology. By shifting the focus from mere task completion to safety under ambiguity, this work introduces a novel and critically necessary benchmark that directly addresses the most pressing challenge for deploying autonomous agents in the real world. Let's break down its key contributions.
At the heart of our work is the UnderSpecified, a new benchmark designed to test how coding agents handle vague instructions in DevOps tasks. It's built around 66 core tasks, which are expanded into over 2,000 different prompts to really stress test the models. Feeding into the benchmark, we have a wide range of tasks, like this clean build cache example, which are all grounded in real-world DevOps scenarios. These tasks are designed to be representative of the kinds of ambiguous requests a developer might actually make. Next, to create ambiguity, we systematically vary each task's instructions along 3 axes: intent clarity, target certainty, and what we call the blase radius. This creates a prompt matrix that allows us to generate many different versions of the same core request, from very specific to dangerously vague. Finally, to evaluate the agent's behavior, we use a set of clear metrics to classify the outcome of each action. We categorize actions as a safe success, a wrong target, or an over-scope violation, while also tracking when the agent chooses to ask, refuse, or defer.
Up next, our 5th paper out of 10, Episodic-to-Semantic Consolidation Without Identity Drift by Xuejin and Jijun Li from School of Software, Harbin Institute of Technology. This paper introduces the novel and critical concept of identity drift in long-running agents, addressing a fundamental tension between adaptation and contractual integrity that is crucial for real-world deployment in regulated environments. Let's break down its key contributions.
Let's start on the right, in panel B, which shows our proposed method. We begin by formally defining the agent's identity using a manifest M, which is then hashed to create a unique identifier, H. Feeding into our system are the agent's episodic events. These are processed by a deterministic function, F, which transforms them into a new semantic memory layer. Crucially, the agent's identity, represented by the hash H, is derived only from the original manifest M. This means the identity remains byte equal and unchanged, even as new semantic knowledge is created. Next, this deterministic process results in a semantic memory layer, which is structured as auditable, read-only information. A separate planner can then access this consolidated knowledge without ever affecting the agent's core identity. The raw and calibrated methods achieve a substantial 79.82% reduction mean, which is significantly better than the uniform baseline that shows a negative reduction. This indicates a strong improvement over the baselines in terms of reduction.
Up next, our 6th paper out of 10, MedStreamBench, a time-aware benchmark for streaming and proactive medical video understanding by Yuan Wang and Zuizhu Liu from College of Computer Science and Technology, Zhejiang University. MedStreamBench directly addresses a critical gap between academic benchmarks and clinical deployment by creating a comprehensive benchmark that evaluates not just what a model predicts, but the equally important question of when it makes a prediction. Let's break down its key contributions.
Our process begins with the surgical video collection, where we gather videos from sources like Springer Nature and IEEE. This raw footage is then re-encoded and stabilized, creating a standardized dataset with an average duration of about 15.8 minutes per video. Feeding into the next stage, the full stabilized video is segmented into a smaller video clip. This use of a bounded evidence window is key to our streaming evaluation, forcing the model to operate on partial information just as it would in a live setting. Next, we introduce a novel proactive task where the model must decide when to generate an alert. This is reflected in our QA pair structure, which includes a specific timestamp proactive to evaluate the model's timing for intervention. Finally, our benchmark validation pipeline introduces new temporal evaluation metrics beyond just answer accuracy. We measure aspects like the model's stability score, which assesses how consistent its output is after the relevant evidence has been presented. On the MedStreamBench, the closed-source Gemini 2.5 Pro model achieves the highest overall score of 0.3728, substantially outperforming all open-source and medical domain baselines. The top open-source model, SmolVLA 3.5-8b, and the leading medical domain model, HuluMed 7b, achieve significantly lower overall scores of 0.2713 and 0.2601, respectively.
Up next, our 7th paper out of 10, Hidden Forgetting in Continual Multimodal Learning, When Accuracy Survives But Grounding Fails by Qinyu Chen and Renxian Tang from Nanyang Technological University. This work uncovers hidden evidence use forgetting, a subtle and critical failure mode in continual learning where a model's accuracy holds up while its underlying multimodal grounding degrades. Let's break down its key contributions.
Here's an overview of our Reliance-Constrained Learning Framework, or RCL, which is a four-step process. The goal is to create an updated model that preserves not just accuracy, but also how it uses different types of evidence. The process begins by taking the model from the previous continual learning step and freezing it completely. This frozen previous mode serves as a stable teacher model, providing a behavioral reference for what we want to preserve. Next, we probe both the frozen teacher and the current student model using counterfactual channel interventions, where we suppress one input channel at a time. By measuring how the output changes, we can estimate a reliance profile for each model, showing how much it depends on the image, text, and OCR. Finally, the Reliance-Constrained Update step uses a total objective function to train the new model. This objective combines the standard task loss with terms that align the student's predictions and, crucially, its evidence reliance profile with the frozen teachers.
Up next, our 8th paper out of 10, AgentGym 2, Benchmarking Large Language Model Agents in De-Idealized Real-World Environments by Zhiheng Shi and Dingwei Zhu from Fudan University. AgentGym 2 is a timely and necessary contribution that moves LLM agent evaluation beyond idealized toy problems to confront the noisy, ambiguous, and complex realities of real-world deployment, addressing a critical need for more rigorous benchmarking. Let's break down its key contributions.
Let's start by looking at the overall structure of the AgentGym 2 framework. At its core, we have an agent that is set up with an initial state and query, and it interacts with a realistic environment to produce an answer. Feeding into this, the framework evaluates agents on complex, end-to-end procedures, not just single tasks. For example, in the data analysis scenario, an agent might have to perform exploration, cleaning, and then modeling in a continuous workflow. Next, a key capability we test is tool discovery, where agents must find and use new tools like APIs or databases on their own. This moves beyond assuming a fixed set of tools is always available. Finally, the framework introduces challenges like unreliable memory to test an agent's robustness. This means the agent must handle ambiguity, such as vague terms and noisy attributes in the information it's given. The proprietary models, particularly GPT-5, demonstrate substantially higher overall performance compared to open-source models, with GPT-5 achieving an impressive 65.68 pass at 3 score. While the thinking method generally improves performance for smaller Qwen 3 models, its impact is mixed, sometimes leading to a decrease in scores for larger open-source models like Qwen 3-235B, A22B.
Up next, our 9th paper out of 10, SPLC, Social Preference Learning for Crowd Robot Navigation by Zishuan Chen and Shirguan Zheng from Wuhan University of Science and Technology. This work cleverly combines offline reinforcement learning with preference learning to solve the notoriously difficult problem of designing reward functions for socially aware robot navigation. Let's break down its key contributions.
First, let's look at the top of the diagram, where we have our social preference feedback mechanism. This component takes sampled trajectories from the initial dataset and automatically generates preference data, which is then collected into a new dataset, DF. Next, this generated preference data is used to guide our offline RL agent. It learns from an experience replay buffer that's shaped by these social preferences, enabling it to develop socially compliant behaviors without live interaction. The SPLC methods generally achieve the highest success rates across the IQL, CQL, and TD3BC categories when compared to HR, HPR, and RPR methods. SPLC CQL shows a particularly strong performance with a 95.4% success rate, substantially outperforming other CQL methods, while all SPLC variants maintain low collision and timeout rates.
Up next, our 10th paper out of 10, 3DLS, a 3D logic stacked architecture for disaggregated LLM serving by Jae-Hun Lee and Ji-Young Kim from KASD. This paper provides a forward-looking and highly credible hardware architecture solution to a critical and worsening bottleneck in LLM serving, representing top-tier systems research that could directly influence the design of next-generation AI accelerators. Let's break down its key contributions.
Let's start with the system-level view, which shows our core 3D stacked architecture. We place a top prefill tier directly onto a bottom decode tier, connecting them with high-density hybrid bonding. Feeding into this structure, a key design choice is the separation of different traffic classes to minimize interference. We isolate the KV cache transfers from other data movements like the decode-side tensor parallelism collectives. Next, for the prompt processing phase, we route the resulting data vertically. The KV cache transfer goes directly from the prefill tier down to the decode tier through these dedicated interconnects. Finally, for the token generation phase, the architecture preserves the existing high-speed lateral fabric. The decode-side tensor parallelism collectives continue to run across the die-to-die interconnects on the interposer. 3DLS consistently achieves significantly lower normalized end-to-end latency compared to both naive planar and PM planar across all evaluated models and datasets. Furthermore, 3DLS also delivers substantially higher normalized throughput, often exceeding 1.2x that of naive planar and outperforming PM planar.
Those were the top papers. Now, let's zoom out. ArXiv received 2,223 new computer science papers across 80 subfields over this window. Here are the trending areas shaping the field. Zooming out, we see AI agents and visual understanding are dominating, while the rapid evolution of LLMs and their governance is particularly striking. Let's take a quick look at each trend.
Trend 1 of 10, Governing and Measuring Agentic AI. This trend explores methods for evaluating, controlling, and understanding autonomous AI systems, including their societal impact and organizational integration. This cluster covers 170 papers. Representative work includes the benchmark ceiling, human judgment, evaluation scarcity, and the political economy of AI capability measurement, 3 futures for the diagnostic radiologist, a structured disagreement about what AI actually changes, and the agentic garden of forking paths. Trend 2 of 10, Advanced Numerical Methods for Simulations. This trend explores sophisticated numerical techniques and computational frameworks to enhance the accuracy and efficiency of diverse simulations. This cluster covers 208 papers. Representative work includes Fredholm residue selection of the unsteady CUDA amplitude, ravines and quantum cost landscapes, opportunities for improved VQA predictions, and Fuse, a partition field exchange framework for coupling physics simulations in FE-Bio. Trend 3 of 10, Visual AI, Generation and Understanding. This trend explores AI methods for both creating novel visual content and interpreting complex visual information from various sources. This cluster covers 266 papers. Representative work includes How Much Future Helps, a controlled study of future privilege supervision for causal egocentric gaze estimation, Cathatrace, diagnosing semantic trajectory collapse in generated visual narratives, and disentangling pictorial cue understanding from language bias in VLMs via depth ordering task. Trend 4 of 10, Machine Learning Methods and Applications, investigates novel machine learning methodologies and their practical applications in various scientific and engineering challenges. This cluster covers 326 papers. Representative work includes I2-REMA, spectral Riemannian representation with temporal attention for mental stress detection based on EEG signals, from approximation to emergence, a theory of deep learning, and a novel machine learning approach for central nervous system tumor classification from DNA methylation. Trend 5 of 10, Robotics and Reinforcement Learning Systems, developing and analyzing reinforcement learning methods for robotic control, navigation, and intelligent system applications. This cluster covers 220 papers. Representative work includes a C2 navigation mesh, adaptive companionship for group-following robots, handling dynamically changing group formations, and world feedback for clinical agents, diagnosing RL and FHIR environments. Trend 6 of 10, LLM prompts, tokens, and agents, exploring how prompts, tokens, and agents influence LLM behavior, safety, and capabilities. This cluster covers 289 papers. Representative work includes mapping text to multiplex graph, prompt compression as Levy-Walk-guided graph pruning, prompt framing distorts count-based evaluation of LLM error detection, evidence for numeric anchoring, and breaking safety at the token boundary, how BP tokenization creates exploitable gaps in LLM alignment. Trend 7 of 10, System Performance and Developer Tools, advancing system efficiency, resource management, and developer tools for building, optimizing, and diagnosing software. This cluster covers 164 papers. Representative work includes SPLC, a flexible, low-cost, distributed file system using serverless designs, adoption and impact of command-line AI coding agents, a study of Microsoft's early 2026 rollout of Claude Code and GitHub Copilot CLI, and GPU Alert, a zero instrumentation process boundary monitor for diagnosing GPU training job failures. Trend 8 of 10, protecting identity and visual privacy. Safeguarding personal visual information and identity from misuse or unauthorized access is the core focus. This cluster covers 218 papers. Representative work includes anti-aesthetics, protecting facial privacy against customized text-to-image synthesis, anti-prompt, image protection against text-guided image-to-video generation, and NeuroBridge, bridging multitask MRI knowledge for neurodegenerative disease diagnosis. Trend 9 of 10, validating and securing complex systems. Focuses on methods and tools for ensuring the correctness, safety, and security of intricate software and cyber-physical systems. This cluster covers 141 papers. Representative work includes information epidemic dynamics in cyber-physical systems, a hypergraph framework with interpersonal relationships, cache merging as a convergent replicated state for multi-agent latent reasoning, and hamgrams, an algorithm for mining regular expressions of bytes. Trend 10 of 10, analyzing and attacking complex information. Analyzing and attacking complex information involves developing strategies to understand, process, and exploit intricate data and systems. This cluster covers 221 papers. Representative work includes optimal universal quantum encoding for statistical inference, adaptive epidemic dynamics on hypergraphs with group-level immunization and rewiring, and an alternative approach toward attacks against fully split PLWE instances.
That's all for today's ArXiv Computer Science Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.